Hello all. In this particular lecture, I will try to explain that what is exactly function overloading. Now, let's say I want some function to perform some task. Okay, let's say the function is, or let us start like this. I'm having some shapes. Let's say circle, then a square, and then a triangle, okay, or a rectangle, or let's say I'm having this trapezoid. So many shapes I'm having. Now, a circle is represented by radius, okay. A square is represented by any x dimension, because this and this will be same. A triangle is represented by A, B and C, three sides, or sometime also by only base and height. A rectangle is represented by the length of it and the width, and a trapezoid is represented by A, B and this spacing. So if I want to write functions for them, then they should be different, isn't it? Because they are performing the same task, that is, let's say area or perimeter evaluation, but for different shapes. For circle, the area is pi r square. For square, it is a square. For triangle of this nature, it is half into base into height. For this particular triangle, what I have to do, I have to find out first S, which is A plus B plus C by 3. And once this is known, then I have to evaluate the area as the square root of S, S minus A, S minus B, S minus C. If this is the case, then it should be length times width, and for this one it should be the half of sum of two parallel sides times the distance between them. Now for these shapes I am interested in writing the functions for area, so they will be different. But the question is, what I am interested in, I am interested in finding out the area only. So is there a way that I keep this name constant for every particular shape, and once I pass the stipulated number of arguments, then it should be giving me a particular type of area, or area for a particular shape? In object-oriented programming, this is very much possible, and that is what we call as function overloading. Means keeping the same name for every function but varying the argument of the function. And function argument variation means either you change the data type of argument, or you do what? You change the number of argument. So by changing either the number of arguments or data type of arguments. So just by changing this, the function will get changed. So how to do this task of writing functions for so many different shapes? So let us try to understand one by one that how this can be done. So my main goal is that I should have the function area for, if I pass this, So this is what this is for, let's say circle. So circle, only radius I am passing, and it should be capable enough to give me the area. Not only this, for rectangle, if I write area and pass 2, 3, let's say, then it should give me what? It should give me the area of rectangle. Okay. Likewise, and let us write and also handle. Now, if I simply say square, then if I only give one dimension, then it should be capable enough to give me the area of square. Or if I give let's say 2 dimensions like this, then it should be giving me the area of C out, and then area, if I am giving let's say 2, 5, then it should give me the area of triangle, and so on. So for every shape you should be capable of doing it. So right now I am taking only these 4 shapes: circle, rectangle, square, triangle. You can extend this concept to anyone. Now let us come to the area function. Area name. Now depending on the argument, it will behave differently. The behavior will be different. So if I pass only double and then let's say r, radius, then return is pi r square. So I can write pi into r, and this is what? This is in double. Okay, this is done. Then this is for circle, because only one argument is there, and this math pi will be there in C math. Now what I can do, I can copy this. Now if I write this is rectangle, so if I simply say int a, and here I return a times a, so it becomes for rectangle. You can see both the functions area previously also having one argument, and this time it is also having one argument. But where is the difference? The difference is in the data type of this particular argument. Now if I, and here as this is integer, so it should be returning integer only. So now if I move ahead and let us say circle, rectangle, and now square. So this is for circle, this is for square, and let us make for rectangle. Int b, now it will become for square, because I have changed the data. I have changed the what? I have changed the number of argument now. So this will be entirely different than this and this. Now comes the triangle. Now this is the catch. Look, triangle is also having two arguments. That means one is length and another one is the height of the triangle. So to segregate it from the rectangle one, what I'll do is I'll make it as double, and here I will also return double, and here I will be writing 0.5 times a times b. That's it. So now what you have done is you have overloaded this function area for evaluating the area of different shapes. That is circle, this is for square, this is for rectangle, this is for triangle. So if you run it now, you will be having this. Look, area of a circle is pi r square. So if the radius is 1, so it is only pi. Okay. Rectangle is length into width, that is 3 into 2, that is 6. Then comes square. So square will be what? A length into length, that is 3 into 3, that is 9. And then comes the triangle, that is half into base, that is 2, into height, that is 5. 2 and 2 will get cancelled out and you will only be getting 5. So in this way, friends, what you can do is you can write your functions which are overloaded, having the same name but with different argument or different data type for the arguments. Now one can argue, this is double, why are you not making it as double? Yes, I can make it double, but this and this will then conflict. So let us say that this is double, and let us say I am also returning double. Remember, whenever we say overloaded, overloaded is also always with respect to the argument, not with respect to this return type. So if I run it now, it will throw an error. And what is the error? Look here. It says that redefinition of double. So you are trying to redefine double. Now you must be thinking, okay, let us write it int. Will it work? No, because the overloading is always with respect to the argument. So if I run it again, it will say the same problem. So now remember that overloading is always done with respect to the arguments. Now I have to make this work. So how can I do it? What I'll do is I can simply say double and 1, and I will remember that if I give let's say it is 1. So if I transfer one more argument to it, so it becomes what? 2 arguments. Now this will be different. And if I run it now, if I run this particular thing now, so this is the conflict with the area here, because double twice, this again. So I have to change something. I have to change here every time. So let us do one by one. So for area I have written 1. Okay. So this is int, no problem. So let us make this double also. Double, and this is also double. Now 1 for rectangle as a square. Okay. And here let us write double 2. Doesn't matter. And here it is double. So let us write double 3. Okay, that's it. I have changed all the functions, and now let us say this is double only, and this is double, this is return type double. So everything I have written double. So what is the differentiation? This is only one single argument. So that's this for area of circle. And if it is for square, then I have to pass one more dummy argument. This will be this for square, sorry, it will be a dummy. So let us pass any number. Let's say I am passing 1. For next one is rectangle. Where is the rectangle? Rectangle this. So rectangle is these two plus one more argument. So I am passing here 2. Just a dummy argument. This doesn't have any meaning. Just to segregate, to differentiate, to know the compiler that this is a different one. And then comes the triangle. So again I have to pass one more dummy argument. Let's say it is 4 or 3, doesn't matter, anyone, you can pass anything. So if you run it now, so still there is a problem. Why? Because again here in this case we are having 2. So let us pass one more, double 4. And in case of triangle, what I'll write, not only this, I will pass one more. So here in totality 4 arguments are there. What are the useful arguments? These. So if you run it now you will be getting your answer, again the same one. And here in this case, what we have made, we have created everything double. So in this way you can overload the function, and as you are overloading the function, in the similar way you can also overload the operators as well. So in this lecture I have told you that how to overload the functions, and in the next lecture I'll tell you that how to overload the operators. So thank you very much. Take care.